Good day, students. So in this clip, we're going to go over some examples on logarithms and exponents to get you ready for the test. So let's go ahead and take a look at question number one. We're to simplify uh, the ratio of exponents x to the 3/5 divided by x to the 1/3. Okay. So to do this, we're going to use the quotient of powers property to simplify this. It basically tells you that if you have a quotient of powers, you just simply subtract the powers. All right. So this is going to become x to the 3/5 minus 1/3. Okay. So just focus our attention on the powers. Just find the difference of these two fractions, and that'll be the answer. Okay. So let's find the LCD of 5 and 3 is 15. So to accomplish that, I multiply this side by 5, top and bottom, and I multiply this side by 3, top and bottom. So that yields x to the 9 over 15 minus 5 over 15. All right. You subtract it, you end up with x to the 4 over 15. Okay. All right. So there goes your final answer. All right. Let's move ahead to question number 2. In question 2, we have the radical. Still want to simplify the 12th root of 64. Okay. So first thing we're going to do is we're going to express this as a power using the nth power property. So to do that, I can express this radical as a power, which is going to be 64 raised to the 1 over 12. Okay. Now let's see if I can express 64 as a power, so I can use the product of powers property to simplify it further. So to do that, I'm going to take 64 and break it down as much as possible. I can take out 2 from 64. I have 32. Take out another 2. I'll have 16. Take out another 2. I have 8. Take out another 2. I have 4. Take out another 2. I have 2. These are all identical, so that's excellent. We have 1, 2, 3, 4, 5, 6, 6, 2. So 64 can be expressed as 2 to the 6th power, and then that raised to the 1/2. Now we're going to use the power products property of exponents to simplify this just by multiplying these two powers, all right? So that becomes 2 to the 6 over 12. I can divide the top and bottom by 2 in this the fraction of the exponents. So divide this by 2. Actually, I can divide by 6. So let's divide by 6, top and bottom. So if I do that, I'm going to end up with 2 raised to the 1/2 power. Okay? So this is the answer in rational exponents form, but I can also express this using the nth property of exponents that I did here to write it as radical. So this can also be written as the square root of 2. So depending on the choices, any of these two answers will suffice. All right, let's move on to question 3. In question number 3, we have a radical of a radical. We have the third root of the square root of 2,197. Okay. First of all, I want to express this radical of a radical as a power using the nth property of exponents. So to do that, let's focus on the exterior first. Since this is the third root, using the nth property, I can write this as the square root of 2197 raised to the 1/3 power. Okay. Notice I held the inner piece fixed, and I just focus on the outside. Now let's focus our attention to the inner radical. Since there's no number here, that means the default number is 2. So that now I can now use the nth property of radicals again to write it as 2197 to the 1/2, and that whole thing raised to the 1/3. Okay. Now I'm going to use the power of a power property to simplify this further. Power property just involves you multiplying it into the exponents, fractional exponents. So you're going to have 2,197 raised to the 1 over 6. You just multiply across numerator and then denominator. Now, can I express 2197 as a as a power? Yeah, I can. Let's see what prime numbers go into 2197, okay? I'm going to test all my primes, and then whichever one goes, I'll just go on from there. So 2197. These are rules of divisibility. I know 2 doesn't go in here because it's odd. If I add all the digits, 2 plus 1 is 3, 3 plus 9 is 12, 12 plus 7 is 19. 3 doesn't go into 19, so 3 doesn't go into here either. This number doesn't end up with 5, so 5 doesn't go. Let's try 7. Divided by 7. 7 doesn't work. Let's try the next one, 11. Since 9, 8, and 10 are all composite, so divide this by 11. That doesn't work either. 2197 divided by 13. Yeah, that works. So you keep testing numbers, prime numbers, up until you get to a number that is bigger than the square root of 2197. So you basically keep testing until you exceed 46. All the prime numbers before 46 are candidates. I mean, before 47 are candidates for trial. Okay, so it's good that 13 works. So let's go ahead and use that. So we have 2197. We took out 13. And we're left with 169. And we know 169, we know that 13 goes into 169 13 times. So the composition of the power form of 2197 is 13 to the third power. So this becomes 13 raised to the third power, and that whole thing raised to the 1/6. Now we're going to use the product of powers, the power of a power property to simplify this. So this becomes 13 raised to the 3/6. We can reduce this by dividing the numerator and the denominator by 3. So that leaves us with 13 raised to the 1/2 power, or using the nth root property, the square root of 13. Okay, these two answers are exactly the same. All right, so there you have it. Okay, let's move on to question number 4. For question number 4, we're going to solve an exponential equation. Number 4, we have the exponential equation 2 raised to the 2x plus 1 equals 1/32. Now, the goal here is if I can get the bases to be identical, then I can use log base that base to eliminate the bases. All right, so can I express 1/32 as the power of 2? Well, let's see. Let's break down 32 like we did before in question number 2. We found out that this can be broken down, right? So 2 goes into 32, 16, 2 goes into 16, 8, 2 goes into 8, 4, 2 goes into 4, 2 times. So 32 is basically 2 to the 5th power, all right? We're going to write this as 2 raised to the 2x plus 1 equals 1/2 to the 5th. I'm going to use the reciprocal property of exponents to reciprocate 2 to 1/2 to the 5th. So I'm going to end up with 2 to the 2x plus 1 equals 2 to the -5. All right. Now the bases are identical, so that's excellent. So what I'm going to do is I'm going to take log base 2 of the left of 2 to the 2x plus 1 equals log base 2 of 2 to the -5. All right. So on the left side, log base 2 and 2 cancel out to the inverses. And on the right side, the same story. And then you're going to end up with 2x plus 1 equals -5. Okay. All right, what we'll do next is just subtract 1 and divide by 2, and that would be our final answer. All right, so subtract 1 from both sides. We have 2x equals -6, divide by 2, and then your final result is x equals -3, and there you have it. Okay. All right. Now let's move along to question number 5. All right, so for question 5, it says that the amount of money A accrued at the end of n years when a certain amount P is invested at a compound annual rate R is given by A equals P times 1 plus R to the n. If a person invests $310 in an account that pays 8% interest compounded annually, find the balance after 5 years. All right, so let's go ahead and work this out. All right, so we're given the formula, so we're just going to use it. Let's list all the things we need and all the things we know. So we're using the formula A equals P times 1 plus R to the n. Note that this formula is the same thing as Y equals A times 1 plus R to the n. Same formula, okay? All right, so let's go ahead and do it. So P is the initial amount. So how much did he start with? He started with $310. What's the interest rate R? The interest rate R in decimal form is 8%. So 8% is 8 over 100, which equals 0.08 because you have to move the decimal point forward twice. Okay? In order to get a 1 in the denominator. All right? So the rate is 0.08. Be careful with this. And N is the period, or how long it takes. Okay? Because when we use this, we normally use T over here for the standard formula. N and T are the same thing. N is for how long? 5 years. And A is the final amount in this formulation. In this formulation, little a is the initial amount. So A is the final amount, which is what we're looking for. So we don't know. Okay, so what we're going to do is plug everything into this formula and compute what A is. So A is basically 310 times 1 plus 0.08 raised to the fifth power. Okay, so that equals 310 times 1.08 raised to the fifth power. So just plug this into the calculator and that'll give us a final result. All right, so let's go ahead and enter that. So we have 310 times 1.08 raised to the fifth power. And our final answer is 455.49. Okay, so A is approximately, this is an approximation since we're rounding. A is approximately $455. Okay, 455. So that answer is our answer is option A. All right. All right, let's move on to question number 6. So for question number 6, the goal is to condense the expression the logarithmic expression log base 5 of 3 plus 2 log base 5 of w minus log base 5 of w plus 6. Okay, so to do this, we want to condense using the product and quotient properties of logarithms, but before we can condense with those properties, the logs must be identical. Okay, so you notice that this is a log on its own, this is a log on its own, this has a 2 as a coefficient. So we need to address this to make them uniform first before we can condense. So to address this, we're going to use the power property of logarithms to power this up so that we can have identical logs. So we're going to have log base 5 of 3 plus log base 5 of w squared minus log base 5 of w plus 6. Okay? Now we can now use the properties of logarithm. Remember, when you're adding the logs, it's the same thing as multiplying the arguments. And when you're subtracting the logs, it's the same thing as dividing the arguments. Okay, so this is going to be a times and this is going to be a divide. So we're going to have log base 5 of 3 times w squared divided by w plus 6. Okay, let's write it, condense it a little bit, just write it nicely. So our final answer is basically log base 5 of 3w squared over w plus 6. And there goes your final answer. All right, so that's that. Well, thanks so much for taking the time to watch this video. Please feel free to subscribe to my channel by clicking up here. More videos can be found on modularextract.com. Thanks again and have a wonderful day.